Hey, welcome back. And for all my fans out there who've wondered what I looked like for so many years, this is me. Hello, everybody. So today we are going to continue on with implicit differentiation, and we're going to start with some AP type of questions here. Now, on the AP, we're going to be using implicit differentiation, and they're going to be saying, how can we apply it? Of course, we can find the derivative, which is what we're asking for the first one. And then for part B, we want to find the slope. And then for part C, if we scroll down here, we want to write the equation of the tangent line at the point that we found. So let's go ahead and get started. Now, in my other videos, I have explained how we get the actual derivative of these. So we're not going to spend too much time on that. We're just going to go kind of into the material pretty quickly here. So to get the derivative of x cubed, that's going to give us 3x squared plus. Now, this is the hard part for implicits. That becomes 3y squared, but it's kind of like an inside. Remember, we can think of that as y it's to the third on the outside there. And when we take that derivative, we have to multiply by the derivative of the inside, dy dx, the derivative of y with respect to x. Minus, now this is where it gets a little bit tricky. Remember this is our product rule. So I'm going to put this in brackets. It's very helpful and smart to put these in brackets. So I'm going to keep the 6 with the x. So my first will be 6x times the derivative of y, which is dy dx, plus the second function now, which is y, times the derivative of the first, which is 6x, and the derivative is just 6. And that's going to equal 0, because the derivative of 1 is just 0. So our next step is to now distribute, get rid of that negative. So that's going to give us 3x squared plus 3y squared dy dx minus 6x dy dx minus 6y equals to 0. These are ugly, but they're not terribly bad, because after this point, we only really care about anything that has a dy and a dx attached to it. Everything else goes over. So this is going to give us 3y squared dy dx, or as I like to say, dwidx, minus 6x dy dx. And I bring everything else over. We get 6y minus 3x squared. Factoring out the dy dx, we get 3y squared minus 6x. And that's going to equal, of course, 6y minus 3x squared. Therefore, our derivative, dy dx, is just going to equal, we got to divide now, 6y minus 3x squared over 3y squared minus 6x. And there's our derivative. All that to get a slope. Now, there's the derivative. That's the hard part on this question. We're done. So, take a break if you need to. And we're back. So let's take a look at the second example here. For part B, we now want to find the slope of the tangent line at our point. And we have this little fancy notation we talked about in my 2 previous videos. If I want to find the slope, that is just the value of the derivative, such that we're at the point 1, negative 2. Now, if you don't really write this notation, nobody's going to come after you, but it's kind of a cool looking notation for us. And that's going to equal, when we plug this in, 6 times y, well, y is just negative 2, minus 3 times 1 squared. On the bottom, we're going to get 3 times my y value, which is negative 2 squared, minus 6 times my x value, which is 1. I'll clean it up a little bit. This just becomes negative 12 minus 3. On the bottom, that becomes 12 minus 6, so we get negative 15 over 10. And there's your slope. You can clean that up if you like. So the last step is to now write the equation of the tangent line or lines at this point. Well, we've been writing tangent lines since like the first week of school, so this should be nothing new for us. To get our point, it's just going to be the 1, negative 2. Our slope, that's what we found up here in part B, negative 15 over 10. Notice I did not simplify. You can if you want. So my tangent line, y minus y1, m, x minus x1, we're just going to write that in, y becomes plus 2, my slope, which is negative 15 over 10, and I get x minus 1. And there is our tangent line. Now the AP says this question should take about 15 minutes, and look, about 5 minutes, and look, oh, there we are. Actually, the AP is going to give you about 10 minutes for this question right here. So I'm going to give you like 3 or 4 maybe. All right, there we go. There's our first example right there. All right, let's take a look at example number 2. Last one. So it says, consider the following curve. Now this is from the actual AP exam. This is from the 2015. And they give us this equation, y cubed minus xy. Once again, we have our product rule right there. And notice, in this one, they actually give us the derivative. They're just saying, show that the derivative is this. Now, why would they do that? Well, if you mess this one up, if you can't take the derivative, they're saying you can still get points. Can you find the points on the curve where y is 1? Can you write your tangent line at those points? And so on and so forth. Can you find where we have vertical tangent? So you can still answer all of these questions even though you can't take the derivative. So because they already gave it to you. But we're going to go and take the derivative anyways. So take the derivative, y cubed. We're going to get 3y squared, taking the derivative of a y. Don't forget your dy dx. Don't forget that. Minus product rule, the first time the derivative of the second. Don't get my first, there's my second. Plus the second time the derivative of the first, and that's just going to equal 0. Distribute your negative. We get 3y squared dy dx minus x dy dx minus y equals to 0. So we can probably go a little bit faster here. Anything that has a dy dx will stay, but I'm going to bring that y over because it doesn't have one. Factor out the dy dx. We get 3y squared minus x, and that's going to equal y. Take solve dy dx, divide by our 3y squared minus x, and we get y over 3y squared minus x. And if you notice, we do get exactly what we started with, okay, which is what you want. Part B. Part B says, find all the points on the curve where now y is 1. So this one, I want to find all the points. Sorry, can't spell. So they gave me the y value. So we know y is 1. We need to find x. So let's go ahead and do that. So to find x, we are going to plug in here. So we're going to say 1 cubed minus x times 1 equals 2. So we can get 1 minus x equals 2, or x equals, what's that, negative 1? And there's our point. There's a point. We got negative 1, 1. There's our point. And easy peasy. You get 1 point for that in AP. You probably get 2 points here, 2 or 3 points here, 1 point there. Part C now says, find the equation of the tangent line. Well, we already have the point. We want to find the tangent line. We already got the point, negative 1, 1. And to get the slope, we are going to look at the derivative at this point, negative 1, 1. And I just plug it in. Plug in the 1, we get 1 over 3 times y squared, which is 1, minus x, but x is a negative 1 here. And we're going to get 1 over, what's that become? 4? 1/4. There's your slope. To get your tangent line, we would take the y minus 1 equals our slope, 1/4, x plus 1. And there is our tangent line. It's so easy. So easy. You guys can do this. This is easy stuff. Good job. Now, part D. This is where it gets a little bit tricky. Part D says, find all the points on the curve in which the tangent to the curve is vertical. Now, in yesterday's video, we said the following. If we're looking for something horizontal, we know that the change in y is 0. Or we'll just look at the top of the function, the derivative, excuse me. if I'm looking for a vertical tangent, we have to look for where the bottom is 0. Because in the vertical tangent, we're saying that if this is a vertical line right here, my pen here represents a vertical line, we're saying that the change in x is 0. Only the y values are changing. The y goes up and down for infinity, but the x's only stay one value. And that's what this says right here. We're saying that the change in x is 0. That's what this says. So let's see here. So when you look at your derivative, we're only going to have to look at the bottom. dx equals 0. We only have to look at the bottom of the derivative, and that's just 3y squared minus x. And we're going to set that equal to 0. 3y squared minus x equals 0. And that's going to give me x equals 3y squared. Now, we found x. We found x. Now, quickly, if x was just 3, how would you find y? That's right. You'd go back up to the original equation and plug in your y. We do the same thing here. Okay? So, I'm going to find y. My original equation, which was y cubed, with my original equation, which was y cubed minus xy equal to 2. I'm going to plug my x in. So that's going to give me y cubed minus, plug the x in, and this becomes 3y cubed equal to 2. Remember, this is 3y squared times y. And if I solve this, we're going to get negative 2y cubed equals 2, or y equals negative 1. So, I still have to find the point. Well, we just said y is negative 1. To get my x value, I can go back here. That means my x was 3y squared, so my x is going to become 3 times negative 1 squared, which is 3. So my point, 3, negative 1. That's a little challenging. That's a little harder. Most students will get this. And they actually give quite a few points for that on the AP. Fewer students will get this far. Okay? It's like they'll give you 2 points here, 1 point this. Okay? All right. Our last example is to take the second derivative. And we did this in the last video. So if we know what dy dx is, we know dy dx is the following. It was y over 3y squared minus x. When we take the second derivative, our notation, taking the second derivative of y with respect to x, there again, the notation is important here. We're taking the derivative of y with respect to x again, and that's why we put the 2 on the x, because x is my independent variable. We're going to use quotient rule here, low, which is 3y squared minus x, d high, which is dy dx, minus high times the derivative of the bottom. Be very careful. 6y dy dx, I'm taking the derivative of y, minus 1, all over the bottom squared. There's my derivative. Now, you may remember from my previous videos, we got to be careful with this part right here. This is an improper fraction. These are our first derivatives. Those are our first derivatives. Now I have an option. Option 1. I can replace them if I want to. But that seems kind of tedious. That's an extra step. So one other thing I can do is I can just distribute. I do want to distribute anyways, and that's going to get rid of my parentheses. So this is going to become 3y squared dy dx minus x dy dx. Don't lose the forest through the trees. This is just algebra 1 right here. I'm just multiplying everything by a dy dx. On this one, I'm multiplying everything by a negative y. So minus 6y squared dy dx plus y, because the signs are going to change there, all over my denominator squared. And again, I have my derivative sprinkled out throughout here. So again, I have my options. Option 1, I could replace my derivative with what I have. But that's a lot of extra work. The other thing we can do, we talked about this, is multiplying by that LCD. My denominator is just this dx. It's the bottom of my derivative. So I can multiply top and bottom by that dx. And if we do that, we wind up with, if I distribute now, we're going to wind up with 3y squared. The dx will cancel, but I'm still left with this dy. Minus x dy. Again, that dx will cancel when I distribute. Minus 6y squared. Again, this dx will cancel. Dy. And the last one, plus y dx. Plus y dx. Let me write that down over here. That's kind of messy. Plus y dx. All over the bottom. Again, it looks nasty, and it does. This becomes just 3y squared minus x squared dx. It looks pretty nasty, and it really is. But remember, I can replace the dy dx, because what did we say dy was equal to? Well, dy is the top of my derivative, so it's just y. Dx is the bottom of my derivative, which is 3y squared minus x. And I'm just going to sub those in. That's my last step I'm going to do. So last step, and then we're done. So I'm going to write it down here. I kind of ran out of room. Equals, ready? 3y squared. Well, what is dy equal to? Y. Minus x dy, which is y. Minus 6y squared. Whoops, grab my parenthesis there. Times dy, which is y. Plus y dx. Be careful. Dx, remember, parentheses are important. 3y squared minus x. All over the bottom, 3y squared minus x. Now remember, I'm multiplying this by dx. Well, dx is just 3y squared minus x. That's just going to make that a cube. Now, some of you eagle-eyed students out there are like, yo, can I combine things? Like I got 3y squared dy minus 6y squared dy. Yeah, you can do a lot of algebra to simplify this, and that's okay to do. You can simplify a lot of this. But if we're just looking for an answer, just leave it alone. All right. Hope you guys enjoyed the video. Smash that like button. See you soon. Bye-bye.